Okay, so this week we were tasked with creating a 4-bit load and shift register. So here is the circuit created. So up here is our NOR gate and 2 buttons. This is the clock, which is connected over here to our flip-flop. And over on this side behind all these wires is the mux. So these 4 LEDs represent the inputs for the load setting on the circuit. This LED over here is our input for the shift setting. In green is our clock, and in yellow from 3 to 0 is our Q outputs. So first, to test out the clock, as I hit this one, the light should turn on. And if I continue to click on the same button, nothing happens. And once I click on the other button, it turns off. And if I continue to click on that same button, it stays off. And if I toggle back and forth, the light turns on and off. Okay, so now to test the shift register. So if I want, say, D3 and D2 on, simply turn them on. And I want to make sure that our mux is in load. So once this LED turns on, only these two should turn on. So perfect. See, I don't want this one on. I want D0 on along with the other two. D0 is now on. So when I toggle this one turns on and this one remains off. And say I want them all off. I hit it so that it goes low, and on the high, they shall all turn off. Great. Now I change the settings from load to shift, and I just want one LED to turn on. So I will input a 1. Then on the high, it should turn just this LED on. And it does. Then I want this light to just shift over to this end of the board. So I will now input zeros. So the input is now low. And as I toggle the clock, the light should move over to this end of the board. So there it goes. Now it's on and it's on the last one. And that's how I could turn them all off. And if I want to turn them all on, I can just leave the S input on and toggle the clock back and forth. And all the LEDs are on. And that's it for this week's demonstration.